Do you see participants joining in?
Yeah, seems Naimish also joined. Should we pull him onto the stage? Oh, there. Here you go. Hello, Naimish. Good morning.
Hi everyone. Hi Rishi. Good morning.
Hi.
Hi,
Ramesh.
Ramesh. One minute. Okay, all set. So we are live. So thanks everyone joining the first ever virtual event of Grafana and Friends Hyderabad. So on demand, now we have gone virtual, and I'm glad to see so many faces. As speaker, our co-organizers are freshly joined. Um, uh, these sessions, we also welcome Ima Wells from Grafana Labs. She's a developer advocate. Thanks a lot for agreeing on the last moment. This is a great value addition for our community in Hyderabad. Yeah. So over to you, Janvi, to
Yeah.
start with. Yeah.
Yeah. Well, welcome everyone once again to the Grafana Grill, the dashboards with donuts, presented by Grafana and Friends Hyderabad. Well, this is our first ever virtual event. So, no city limits, no travel, and no excuses, just you and your browser. And as Satpal already introduced all the co-organizers, coming to the Satpal, he is our organizer for Grafana and Friends Hyderabad. He works at UBS, and apart from that, he's a CCAT champion and he's a cloud and AI architect. And he's an active community leader, and he's into knowledge sharing and technology evangelism. So fortunate to be joining with Satpal, all of us as co-organizers, and we have Rishi Niklesh, the manager of software engineering at Motorola Solutions, and we have Rahul, the staff DevOps engineer at Silicon Labs, and we also have Navneet Krishna, his software engineer at Rapid Node. So it's an amazing community where the talks and whatever is happening is actually meaningful. It's not just meetups or events for event's sake, it's actually for community building. We are so fortunate to be part of this community, and I just also want to thank all the speakers present over here, Naimesh, Abhishek, and especially Ima. Thanks for joining. So we have the speaker right from the Grafana Labs, Ima Valls Burners, and she is a staff developer advocate at Grafana Labs. We are so privileged to have you joining with us today. Thank you, Emma, once again. And well, I hand over the session to Satpal now.
Yeah, thanks, Janvi. Right. So Janvi has already introduced Ema. I have I'm getting a lot of queries around how to start contributing into a CNCF project, where to start, how to start. People get confused. There's so much of documentation. On GitHub, there are so many links, so many SIG meetings happening. All right, so people are clueless. I think Ima's session will give clarity and also confidence to the first timers or 58 timers, those who are still looking for contribution into open source. So she will deliver a talk on that. Over to you, Ima.
Thank you. Thanks for inviting me, Sepal, and everyone. Jan, very nice to meet you and Raul and
Yeah,
Rish and all the co-speakers. It's an honor to be here with you all. I don't know if you can share my screen. You can start with the slides. Thank you. So, well, I'm very happy to be here with the Hyderabad community and I guess more people because this is online. So this is very nice. This talk it's inspired because I'm more than 50 years old, so I always thought it would be too late to start contributing to open source. And at some point, I thought, well, maybe it's not too late, and I was able to do it. So I thought I'd be able to inspire other people to do the same and give you a little bit of hints into what was my journey until I contributed. So this is a little bit the agenda for the talk today. I'll start with a bit of my journey, of my background, where I come from, and how I ended up here, which is interesting probably. My learnings in this journey, and then finally, probably the thing you're most interested in is how you can contribute to the CNCF and open source in general as well. So with my journey, I actually was born in a farmhouse in the middle of nowhere. So my mother loved cats, so we used to have like 40 cats at home. I was born without electricity even or telephone. So for me, being now where I am, it's like a huge change. I live in Barcelona, in a big city, and I'm an OpenTelemetry member now. So it's been a huge journey for me, and I hope it's interesting. When I was young, I was actually sent to a boarding school. So I was there with nuns, which probably was good for me in a way because all the teachers were women. So for me, maths and chemistry and all these subjects that sometimes are for men were the teachers were women. So that for me was like a role model that a woman could teach maths, could teach chemistry. So for me, that was pretty good. And also, I was lucky that they sent me to coding class because my brother wanted to study computing. So my parents decided, okay, we'll send both of them to coding classes on Saturdays. And that's where I actually learned that I loved it. So I was the only woman in the room, but the only girl, but I realized I loved it. So when it was time to study, I went to Barcelona, to a big city, to get an engineering degree. And then I started working in traditional companies, insurance, banking. I've done Java in my life, so usually the traditional things. And then, that was in 2005. And in 2018, I was able to change a little bit my career. It's when cloud arrived, Kubernetes, and all the stuff. And I was able to join Elastic, which is a company in the observability domain. And then I joined Grafana. So for me, this is when I actually did the change into the companies that support open source. And it's when I started thinking, maybe I can support open source. Maybe I can actually do something about that. The first thing I did was volunteer in communities like this one, Grafana and Friends Hyderabad. And I really enjoyed it. My first community was software crafters in Barcelona, but I contribute to many other communities here. I'm a very passionate community builder. And I thought Well, I don't know, only want to contribute organizing communities. I'd like to contribute to give back to open source because we all use open source. I thought it'd be nice if I could do a pull request, if I do something that shows that I'm also giving back to the open source community. Because I'm in the observability domain and I love monitoring and all the stuff. I'm also a cloud native Barcelona organizer and I love Kubernetes and all the stuff. I decided to try to contribute to the Kubernetes operator in OpenTelemetry. I didn't have a very good experience with doing that. I didn't feel very welcome probably, or I didn't feel I fit. And I was lucky that I decided to change to the OpenTelemetry documentation. And this group was really welcoming to me, and I was really able to do a contribution very, very quickly. So I felt like this was actually my place. And I have to thank these people actually for this, and this is one thing I will recommend, is try to find the team then where you feel welcome, where you are supported. These were great allies for me, great sponsors. So I do recommend that if you don't like the first project that you're starting to contribute, or you don't feel that it's your place, do that. So in this team, I started doing Spanish translations. It seems like I didn't know that this was actually a thing. So because of we want technology to be accessible to everyone, it's good to have documentation in different languages. So this team is actually dedicated to translating the OpenTelemetry documentation to Spanish, something that you can do also as well for your languages. I think that's a Bengaluru one. So it's a good thing if you can look into what is happening there. And in this slide, what you see is that this team was very helpful to me. Carol Valencia, the one in the middle, she gave me these instructions in Spanish on how to actually do a translation step by step, super easy to follow. So it was very easy for me to do the first pull request thanks to her help with that. So that's why I say this team was super helpful. Carol, when she saw that I was trying to help, she immediately asked me to do a call with her to go through all this documentation and help me how to do it. So it felt very easy. And what's more important, even, this group was super amazing with me because after I did just a few pull requests, they actually reached out to me and they said, "Do you want to become an official member?" I was like, "Oh, yes." And they made it super easy for me to feel welcome and included in the team. And thanks to them, I'm an OpenTelemetry member now, and I feel more recognized for what I do. One thing that's nice about the Cloud Native Computing Foundation, the CNCF, is they have this contrib card where you see actually your contributions to the repositories. And there's also one of the ambassadors, I think, that created these dev stats where you can see actually how many contributions you are doing, how many issues, how many pull requests. So it's really nice to follow up on what you're doing. But actually, what I realized after that, when I did my first pull request, it was, I've done a few pull requests, I'm already contributing to open source. But then I realized, no, there's also many ways to contribute to open source. It's not just code. So then I realized I had been a Cloud Native member for 2 years already, so I was already contributing to open source. I organize sometimes Cloud Nativos Spain or KCDs, so it's something that I have already been doing. But for me, in a way, I felt that I needed to do a pull request to contribute, which is not actually the case. So about my learnings for this journey, the main one for me is join the right project for you. There's a lot of contribution groups in the CNCF. The 6 are special interest groups. So join the one that actually works for you, where you feel welcome. There's a lot of different people, so you'll find your place. Listen to the contributors, read the contribution guides for sure. They will give you good advice, so try to follow that. For example, in our case, some people were doing huge pull requests, and the maintainers say, don't do huge pull requests, just do small changes, just 1 page at a time. Don't do 10 pages at a time because it's a lot. If there is a lot of errors or things to correct, then there is a lot to review for the reviewer. So one of the things they recommended is just do small changes for starters, don't do a big thing. So for me, that helped, like being, I could contribute faster because it was a smaller thing to do, and also felt that it was not so much to correct. So, and also one thing that's important, it's try to be consistent and realistic with the time that you have. We all have a job, we all have other things to do. So don't try to overdo it. You will gain the trust of the teams if you actually show up consistently and are realistic about the time that you can dedicate to it. So I would recommend that as well. The other important thing, as I said, I always thought that contributions were only code, but no, it's not only code. There's many ways you can contribute to open source. So just find the way that works best for you. The other thing that's important for me, it's amazing because I work at Grafana Labs, is some companies support you contributing to open source in your working hours. So if you can work in companies that support that want to give back to the community as well, this is amazing. And finally, have fun, because if you're not having fun, if this is, it's not something that you will stick to it. So I would say, don't forget to have fun. And finally, I think the last section you might be more interested in is how you can contribute. So the Cloud Native Computing Foundation is a foundation under the Linux Foundation, and it was created to foster the open source ecosystem. For cloud, it promotes collaboration and community. There's a lot of community groups, for example, the one I am in Barcelona. And it's also the one that standardizes and educates the community on cloud native. It is a huge community. It's a very big community. This year, this year it's the 10 years of the CNCF. Last year, it was the 10 years of Kubernetes. It has hundreds of thousands of contributors. There's more than 200 projects where you can contribute. Kubernetes is the most well-known. You can see in this URL, if you visit it, that is the velocity of the projects. And the second one is OpenTelemetry. So this is a very interesting thing. So this, I think for me, this slide that I saw from the CTO of CNCF, it's really interesting because it separates the two types of contributions. There are code contributions in open source, but that also are no code contributions. And here is the landscape for the Cloud Native Computing Foundation for the CNCF. There is the Technical Oversight Committee to the left, where they have technical advisory groups. They have this contributor dev that we'll see later, where you can find your contributions. And you can see there's more than 1,200 projects and growing that you can actually contribute to. And more importantly, if you don't want to contribute code for starting, sometimes you don't, there are the no-code contributions. There's a cartographers working group. If you've seen the landscape of the CNCF, this is the group that actually creates this huge landscape of all the projects and tools that are available for Cloud Native. You can write a blog post for the CNCF in general on all the projects for Kubernetes. You can contribute to the glossary of the Cloud Native and also all the project documentations, which is where I'm contributing at the moment. It's a very good contribution to do as well. If you want to join the community, there's a Slack. This is where everything happens. If you're not there, I would recommend you join. There's also community groups. I know there's a lot in India and everywhere. So also a great place to connect with other cloud native passionate people. And then there's a mentorship program that's also very interesting. If you join the program, for a few months you work with a mentor and you actually contribute something together. So it's a really interesting way to start if you've never contributed. I didn't go that route, but maybe I should have. I was lucky that the people mentored me in an unofficial way in the documentation team for OpenTelemetry, but it's also something that it's very interesting to consider. So if you want to get started, where do you start? There is this Contributor Dev website where you can see all the projects and you can pick the ones that are good, are labeled good first-time issues, and that's actually really a good way to start. If you see here below, I opened just one issue a while back for OpenTelemetry, because when you're translating pages, usually they drift. I mean, you have pages in English and in Spanish, but sometimes they update the page in English and you need to update the page in Spanish. So I open an issue to track that, which pages have been updated in English but not in Spanish. So one of the people I know from Amsterdam, he reached out and said, "Hey, so you opened this issue. Do you need help? I'm available, so I'll try to help." So this actually is very useful for people to find the issues where help is needed. And I would recommend, if you have to start, go there, find a project that you like, and try to find issues that you like. The other key thing for contributing is that we usually need time to contribute, and that's probably one of the biggest issues. That's why I said, if I'm very lucky because I work at Grafana Labs, and we are one of the main contributors. For example, in OpenTelemetry, we are one of the top contributors right now, and we are allowed to do that on our own working hours. So I would say, if you can, look at these statistics and find the projects that you like and what companies are contributing to them. And if you can join those companies, that would be easier than otherwise. But anyway, you can always make time. Before I work at Elastic and Grafana, we could always make time to do that on your own. So the main takeaways to finish the talk, hopefully in time. It is never too late. So for me, I started almost when I was 50 years old, but it's anyone can start. I mean, I always felt that it was not something I could do because I was too late, and it's not. And the same thing, it's never too early. So you can always contribute to open source if you want. My recommendation, find the project that you are passionate about. In my case, it's OpenTelemetry because it's in the observability space, it's monitoring. It's the standard that it's gonna be it's vendor neutral and everyone uses. So for me, it was a very the project that actually motivates me the most. All sorts of contributions are welcome, not just code. So sometimes we think I need to be the Golang expert to actually contribute. It's not the case. I'm not a Golang expert. I used to code in Java. So for me, it was one of the things that say, okay, maybe I'm not a Golang expert. How can I help? There's a lot of contributions. It's not just code. So you can contribute with documentation, translating documentation, creating new documentation. You can contribute to the glossary. You can write blog posts. You can do all sorts of things if you're interested in contributing. You can organize a community group. There's so many things that you can do. It doesn't have to be code. Also start small, be realistic and consistent. Don't try to overdo it because then you might burn out. So just start small, see how it goes for you. Be flexible. If you need to change, you don't like this project, you want to change to another one, that's okay. If you can, seek the companies that support open source when possible. And don't wait to start. For me, I feel like I waited for a long time, and have fun while doing it. So just to close the talk, I'd like you to think for a minute what you can do in the next week or next month. What project would you like to contribute? And pick it and try to help. And that's all for me. I'll leave you with the QR code of the slides if you want to get them for some links and have all this information. And well, thank you very much for listening and for having me.
Well, thank you, Ima, for the lightning talk. It was really amazing. And thanks once again for reminding that it's never too late to start contributing. Thank you. And well, Ima is like, she embodies the true spirit of open source, observability, and community first engineering. And Ima has spent over 2 decades working across software engineering, cloud architecture, and platform reliability. And she has built large scale enterprise systems as well. Before joining Grafana Labs event, she held impactful roles at various organizations and she led cloud, Kubernetes, and observability initiatives. So we're so privileged to have you here, and thank you for sparing your valuable time and giving us amazing insights, Ima. Thank you once again for
Thank you for
starting
having
this
me.
session. Yeah.
Thank you so much, Eva. That was so insightful. Yeah.
Thank you.
Thank you so much, Iman. It's really amazing to see your contributions, and we are now motivated to take up the open source contributions. Uh, it's general notion that when we talk about open source, you should contribute via code or pull requests or code commits. But this is an eye opener for us. There are many ways to contribute to open source, and yeah, thanks a lot for briefing us out, and hopefully, yeah, we'll start our journey towards the open source contributions right now.
Yeah, I can say that when you start with other types of contributions, it also opens you the door for code contributions because you get to know the teams, you get to know people, and then you can do code as well. So it's not that you start in a way and you have to follow only that, but it opens you a space to do whatever you want.
Yeah, that's true. And one last closing comment. These days, we have been witnessing few companies who are fostering inner source rather than open source. So they call it as inner source, meaning they want to use the open source but build those custom tools and functionalities and keep it to their organization so that only those teams can be share, those custom tools. So they call it as inner source
Yeah,
due
yeah.
to some regulatory or any compliance requirements. But yeah, I think open source is something which is stand tall across all the tech stack because you should not be just consuming, rather, in a way, you should be contributing so that everyone goes, grows collectively.
Yeah, you made a good point in your source. When I was working at the bank, we started looking into that because it's a good way to have the same culture of open source internally, where everyone contributes to a common project. So I think it's also a good way of learning how to contribute. So if your company does that, that's also amazing. Yeah.
Yeah, thanks, Ima. So
Right.
in the interest of time, I'm going to say only one thing. So my open source journey started in similar way, whatever you mentioned. So I met Satpal, and I think that's how I joined this community. That's how I wanted to contribute to this community. I'm starting with this now. Thank you.
Thanks, Rahul. Thanks, Ima. Thanks, Rishi. Over to you, Janvi. Sorry.
Thanks, Hima, once again for such a incredible lightning talk. And I think there is a lot of energy you have filled in the session. And next, moving on to our next speaker, it's Naimish Kevaria, and he works as software engineer at Motorola Solutions. And today he's going to speak about architecting zero touch observability for the edge. And I request Rishi to give introduction to Naimish. Yeah, handing over to you, Rishi.
Yeah, thanks, Janavi. Thanks all for joining in today. So we have our speaker Naimish coming up. So he is Uh, I use the word star performer because he's from day one. He's the pioneer of our tech stack in our team, and I'm not exaggerating, but he really set our bar very high when it comes to architecting the solutions, taking forward, delivering the things on ground. And he primarily works on Prometheus and Grafana stack, and he's very passionate about the observability as a whole. So it's a true privilege for us to have him on board and in our team. So I heartily welcome Naimish to take over. So over to you, Naimish.
Thanks a lot, Rishi, for this wonderful introduction. First of all, thanks, Ema, as well. This was really inspiring talk. I know many people like me will get inspired and start their open source contribution going forward. So thanks a lot, Ema. So let me start presenting.
Yes, Nimisha. I was about to tell you that.
Is my screen visible?
Yes, visible now.
Yeah, we can say.
Okay. All right. So hello, everyone, and welcome. This is my first talk virtually in Grafana and Friends Hyderabad meetup. So we are here to talk about architecting zero-touch observability for the edge. So now observability is a buzzword that we hear constantly, right? We have solved it for cloud. We know how to monitor it as GCP, Azure, or any Kubernetes cluster running on in any data centers, right? But when it comes about the edge, the rules of physics and the networking changes. It's a completely different system. The challenges are pretty much nuanced there, right? So today I'm going to share our journey. It's the story of how we moved from a fragmented monolithic monitoring on edges to a completely autonomous way of monitoring the observability on edge devices, right? A system that we treat like edge device is not like a mini server running in some data centers, right? But those are appliances that needs to take care of themselves, right? So here we are speaking about architecting zero touch observability for the edge. All right. So before we deep dive into the architecture, a little about me, myself. So I'm Namish, working at Motorola Solutions. I'm part of a larger platform team at Motorola. My career has been defined as a specific obsession that is building a robust tooling and platforms for our developers to build their systems on top. I've led several and built several projects in the observability domain in Motorola. My background is deep in cloud native technologies. I've grown up with the open source toolings with my professional career. Right. I'm also a certified Kubernetes administrator and a professional architect in Google Cloud. Right. But applying this cloud native principles on the edge was a unique challenge. I had to unlearn a lot of best practices that will work in cloud but will fail miserably in a two-core compact device sitting on a dusty table, right? So that's what we are discussing today. So yeah. So let us define our battlefield first. What is edge? When I say edge, I don't mean a secondary data center. I mean a physical point where the digital world meets the real world, right? These are the devices which sits on the edge of the network, which generates the data on the edge, right? Think about a camera on a traffic light. Think about a robot arm on an automotive factory floor. Think about a POS kiosk on a restaurant from where you ordered your coffee today morning, this morning. So these are all the examples of the edge devices, right? These devices are specifically have some nature, like they are resource constrained. They don't have fancy 32 GB or 64 GB RAM on their hardware. They often run on legacy hardwares, uh, old school hardwares. Like they are dusty, they can get hot, they are still critical to business operations, right? If think about if that factory robot stops, your business operations are stopped. The assembly line will stop. So we need to know if it's healthy, but we often treat this device as like a second-class citizen of a cloud server, right? So that is what the reality is now today. So let's move on to the next. So why is this hard, right? We can't just do what we do in cloud on the edge. So let's break it down into four different points that I feel that is more relevant to this discussion. First thing is edge devices are quite distributed in nature, right? We aren't managing 50 server in some fancy data center in US East 1 region of a cloud. We are talking about thousands of devices spread across multiple buildings, multiple cities, multiple areas of a state or a country, right? So they are quite distributed in nature. Second thing is resource poverty. As I said earlier, these devices are poor in resource pool. Every megabyte of RAM we use for monitoring is like stealing uh, the same memory from the actual application that runs a critical workload, right? So this is more important when you talk about the edge devices. So we have to be really greedy with the resources that we run the applications on these edge devices. The next is the bad networks. Since this devices sits on the edge of the network, connectivity is intermittent. In a data center, when a network drops, we treat it as an incident. But when the connectivity drops in an edge device, it's like any other normal day, right? So if monitoring agent crashes and never start because the internet flickered, the point of observing the edge device is completely useless. There is no point. Every time a operator has to go start the your monitoring agent, it will take a lot of friction, a lot of escalations from customers. The next thing is the security risk. Like these devices are physically accessible on many places, right? Someone can walk up to an ATM or a kiosk or steal the device if the device is compact in size, right? So we cannot have any hard-coded credentials, API keys, or open ports on these devices. So currently, most companies suffer from this sort of issues who are working on these edge devices. They have complete blindness or on what is happening on their edge devices, right? This leads to a lot of escalations from the customer. When an edge device goes down, customer will escalate it to the company. The company will send the operator, take few hours. Operator will go there, debug. The issue was very small. For example, disk which was storing the logs was full, which can be automated with your application, flushing the disk. Simple few minute task will lead to 10 to 40 hours per month for restoring an edge device, right? So our solution was to embrace a hybrid approach here, right? We stopped trying to make the edge act like a cloud. Instead, we decided to connect the edge to the cloud to get the benefit of both the worlds, right? So the edge should be responsible for collecting, buffering the data. It needs to be autonomous. The cloud should be responsible for storing, analyzing, and the alerting the health of the devices. We don't process the data on the edge. We just catch it, package it, and ship it to the cloud. And the separation concern here is the vital. Yeah. So the next is why traditional monitoring fails. So I want to take a pause here and tell you what we tried first and why it failed. First thing, most traditional observability agents, which are enterprise grade, are very heavy in nature. We have tried with Logstash running on this edge device, and it took almost 1 GB minimum of memory for a device of a 4 GB device. Right now, think about that 1 GB of memory is just required for collecting your logs from your edge device. The remaining 3 GB is what we are left for running your critical applications, which is a non-starter for us, right? The next is the manual work that we have to do on the edge devices. Think about upgrading. You want to upgrade your system, or you want to change a very small line or a very small endpoint in your edge device. You have to run manual scripts. Think about doing SSH into 1,000 devices, running a simple curl command on the edge device. Half of them are offline. Half of them has a different OS version which does not support your upgrades at all, right? So it is a lot of manual work, lot of waste of human hours, right? And the next thing, the biggest issue here is it's a completely fragile. As I said earlier, network connectivity drops quite a lot, quite often, right? So if the network cuts, the agent would often buffer the data until it run out of the RAM of the device. It will crash, and then it will never start. It will stop sending your data, and it will never reconnect. So we needed something that should survive a power cycle, a network cut, a resource spike without a human intervention or a manual reboot of a device. So we thought of core strategy. We built a new strategy around it. The first thing was we should leverage the containerization at its best, and which was Podman over Docker. Why? Because it's a daemonless and a rootless. It's if the container crashes, it does not take down the entire daemon. It also more secure by default because it is a rootless daemon container running as a rootless process. Right. We have also leveraged the Quadlet along with the Podman. So Quadlet it allows users to manage this volumes, pods, networks, images declaratively. You do not have to run a Podman commands like Podman run container, Podman download images, something like this commands on manually on the edge devices. We use a declarative file which lists down all the configuration of the container, and we just ship it to the device. And this Quadlet files are handle with the systemd unit files. Basically, they are systemd unit files framing container management. So this streamlines the container management on an edge device. We do not need a fancy container orchestration like Kubernetes on this small compact devices. And next thing is the standard tools that we chose. We did not reinvent the wheel, though there were few resource constraint that we had to keep in mind. So we chose Prometheus for metrics, Fluentbeat for logs, shipping the logs. These tools are quite better tested, right? And then next comes is the glue that connects both the worlds, edge and the cloud, and that's where the ops agent was born, right? So this is the kind of custom glue which runs. So we instantly realized we cannot just run Prometheus on an edge device running as a Podman service. Why? Prometheus is pretty good, better tested in environments like Kubernetes, Docker, OpenShift, this sort of environment, because it has a pretty much robust, mature auto discovery system built into Prometheus. But when you talk about Podman, it does not have any sort of auto discovery module. It cannot discover any containers, any candidates, any targets for uh, uh, as a valid metric scraping targets, right? So here the Podman, here the ops agent will help us, right? It handles the life cycles, it handles the upgrades, it handles all the configuration, not just for Prometheus, for Fluentbeat as well, for entire observability stack. So and the core principle here was that we do not want to store any data on the edge device. We will ship it to the centralized observability running on hosted cloud environments. Right. So even if the edge device goes down, we do not lose any data, any telemetry on an edge device. Yeah. So let's slow down. Let's look at the architecture. Let me start. Yeah. So it starts with the cloud. Every edge device. So this is an edge device. We have a provisioning system for edge device. So every edge device is loaded from the provisioning system, which is connected with the cloud, right? All our container configuration manifest secrets are handled from the provisioning system, right? We have a messaging queue in between where provisioning system will send this container configurations and its access tokens to the messaging queue for each and every device. On each device, we have a connector which will listen to the messaging queue. Whenever a configuration is passed to the messaging queue, connector will get it on the fly and it will pre-install all the configuration on the edge device. So this is the connector between edge and cloud. I will not deep dive into this. This is a pretty vast topic for any other talk. We will completely dig it from our observability talk this time. So I'll park it for some next session. So this is the basic architecture, which will allow us to handle the edge devices, onboard edge devices from the cloud. One more thing is that let's suppose you have 1,000 of edge devices here, right? Let's suppose your provisioning system sent a configuration, you want to update your services. What if half of your devices are down or shut down or they are not available? How will you update it, right? So that's where this sort of inversion of control will help you. Messaging queue does not send the data to connector. Instead, connector will pull the data from the messaging queue. So whenever a device is offline and it will come online, instantly it will pull all the configuration, all the messages from the queue, and it will start upgrading the device whenever it comes online next. Yeah. So now let's meet the brain of our operation, that is the obsidian. It is an intelligent, lightweight, self-managing observability solutions that is built in-house in Motorola. We had a philosophy here. It is the zero-touch enabler. The philosophy is like install once and never touch it again, right? It requires, so it handles all the boring stuff that usually would have required a human manual intervention for an edge device, right? So it prepares the ground before the actual match starts, pre-configures the device to run all the observability tools like I talked about earlier, like Prometheus, Fluentbit, several custom exporters to monitor the edge device, right? It helps us auto discovering the targets on running on the Podman environment. It also helps us in managing the security tokens. I'll talk about more on going forward. Hot reloading Prometheus and Fluentbit for any sort of configuration change, any sort of access token change in the Prometheus configuration, right? So it's essentially a kind of robotics system living inside your inside a container on your edge device. So yeah, so we promised a zero touch. So let's take a look at the installation volume. So the installation runs as a sort of one-shot process. One-shot meaning once it will come up, whenever container will be live, it will run only once. Once the task is finished, it will go in exit state, right? Uh, so the reason we chose one-shot process was that it should not run as a daemon inside our container, right? It should be just one-time job that helps us managing our memory. It should not start eating a lot of memories on the edge device continuously, right? So here is the sequence. It reads the package of the data, package data residing in the container. It sets up the file system for any sort of directories, volumes, any sort of parameters that requires for successful operation of our observability components. It pre-configures the device for Fluentbit, Prometheus exporters, even Prometheus verifies the status of all the components, whether they are running healthy or not, and exits. So this is the installation logic. It's pretty simple, right? This entire sequence takes less than 5 minutes. You can rerun it 100 times on an edge device, and it's idempotent. It won't break anything if you run it multiple times. This is reliability kind of that allows us to push updates aggressively on any edge device. If you don't do this, the upgrade process on this edge device would take months because it would require a lot of manual efforts. Yeah. So this is the most technologically interesting part. That is the auto discovery. In cloud, Kubernetes does this for you if you run Prometheus in that Kubernetes environment. But at the edge, on a raw Linux box, we don't have Kubernetes APIs. So instead, we are building our own auto discovery, right? We are using two things here, target discovery and inbuilt auto discovery, that is file-based auto discovery available in Prometheus. We are using these two features. All right, for target discovery, we have specified several labels. We have predefined several labels, which we will query the Podman APIs. Basically, Ops agent will query the Podman APIs at every 5 minutes, collect the metadata of all the containers running in Podman, identifies a container as a valid candidate for scraping the data or shipping the logs. We fetch different parameters like port, path, scheme, different scrape interval. If someone has custom requirement for certificates and path for authenticating between Prometheus agent and the container. So this metadata we will fetch via Podman APIs. Once done, we will generate a JSON file of the target with all the metadata. And once this task is done, it will slip till the next scheduled run, next 5th minute scheduled run. Right. So we will build a target JSON file. This target JSON file is provided to Prometheus for this discovery. So when Prometheus will detect a newly updated target file, it will automatically reload all the new targets. Right. It will initiate the scraping at the very instant moment, and you will be able to see your data in your remote telemetry or in your company, right? So this means a developer can deploy a new app to the edge without a fancy kind of configuration. They just have to add label on their containers, and it will start instantly appearing in your dashboards. No need of creating any tickets to your DevOps team or platform team. This will help us reduce a lot of friction between our developer teams and our platform team. So here is a security part. We have a strict rule: no credential, no API keys, no service account stored on the disk. So what we do, we pull the secrets from the messaging queue that I talked earlier, which will be sent by the provisioning system every frequent interval, and we will inject that access tokens on the device as form of Podman secrets. Now this tokens will have a validity, let's say 2 hours or 6 hours. Within that validity of period, our Prometheus agent or FluentBit will be able to send the logs or metrics successfully to the device. Once the validity expires, it will no longer be available, no longer will be connected to the cloud. So we have to rotate this secret at every frequent interval that we have defined, right? So what we do, once the secret is available in the messaging queue, it will be injected into the device as a Podman secret. Ops agent will read that secret and provide those access token to the Prometheus and FluentBit as a handle. It will handle this secret, hand over this secret to the Prometheus and FluentBit as a secure manner. By this, we reduce the possible attack duration if the device is stolen or mishandled. Yeah. So here is a final assembly. We have Ops agent will pull the data from all the containers running as a Podman container on the device. It will pull all the metadata, and then it will generate the target files based on the labels that are identified during this process. This is the part of the auto discovery. Once the target files are generated, these files are fed into Prometheus agent as a configurations. It will start reading the target files and start pulling the metrics from the containers and exporters. Similarly, for FluentBit, we have several labels from where to route your logs on your centralized observability for better RBIT and audit purposes. Logs are more critical in nature compared to the metrics, because metrics are more sort of engineering focus in nature, while logs could have more PIIs or sensitive information about the application. Right? So we need a lot more governance on the logs rather than on the metrics. So we add several labels to route the logs on a specific index on centralized observability. FluentBit and Prometheus both cannot automatically report the configuration changes. I talked about the access token API keys that gets rotated every few hours. That needs to be fed into the configuration of both Prometheus and FluentBit. So we had to build an hot reload configuration update as well, so that FluentBit and Prometheus will keep running without any issues, without any disruptions. So as a matter of building our observability stack on edge devices, we had to consider few optimizations as well. As I said earlier, we tried a lot of enterprise agents for collecting the data. And at the end, we chose Prometheus, not in the full-fledged server. We rather chose Prometheus into agent mode. We chose FluentBit over other enterprise-grade log collectors like Logstash and FileBit and this sort of collector. This helped us save significant amount of memory and compute on the device. If I give you the estimate, our entire observability stack, including the ops agent, uses less than 250 MB of memory and less than 50 millicores of CPU on the device. This gives a lot of headroom for our application team to handle their application more robustly, more gracefully on the device, because they have more resources to run it. The next optimization we chose was to use distress security hardened images. All the images that we build are security hardened in a way that they are built with the encryption modules which are certified with the FIPS standard. FIPS is a regulatory standard from the US government, and all our images are certified with. If I talk about our earlier initial images that we used to build Observability on edge device, our image footprint was over 5 GB, including all the images of all the containers that we use. By choosing distroless image, multi-stage building of the image, we reduce it from nearly 5 GB to 500 MB. This is the storage that we would have needed on the edge device root file system, and this is a improvement that we have done. Since this images are security hardened, no shell, no package manager, nothing for an attacker to exploit. It has almost near zero CVEs. And even if we get any critical CVEs, it will be very easy to upgrade the system due to our fluidity nature of system, from provisioning system to messaging queue to edge devices to the quadlet files and system D unit files. So here's a small glimpse of what it will look like at the end. We have we have we are monitoring these devices on Grafana, pulling this. This is basically a Prometheus metric data. We will monitoring all the CPUs, memories, root file systems. We will also be able to see if the device is down or healthy. How many are total devices? How many are out of total devices? How many are healthy? Where we should act upon if the device is removed or it is actually down. Uh, yeah, this is more granular way of monitoring uh, the devices, and it would have been incomplete if I have not shown this Grafana dashboards in Grafana Meetups. So I'm really happy about it. Uh, use currently different exporters like Pod Exporter for monitoring OS level data. We use Podman Exporter for getting the Podman level insights. We also pull the metric of flu and bit to know at what frequency we are ingesting the logs, if we are buffering our logs at optimum level, if we are lagging behind, if we have some headroom, if there are some issues with shipping the logs, etc. So yeah, to conclude, the edge is unforgiving. It requires a mindset shift from managing servers to managing plates by leveraging CNCF back. If you notice, all our text that we use on edge device, all are CNCF backed open source tooling, and we have built a custom glue, which is a smart agent like precision. By this, we were able to achieve a zero touch observability. So yeah, I'm closing this talk with the thanks to all of you who joined virtually, and thank you from the edge of my heart. And open for questions.
This is really great, Naimish. I mean, the end note is quite fascinating. If you go back to the previous slide, thank you from the edge of my heart. So that is kind of synonymous to your uh, the talk till now. So hats off to your creativity. But this is really great session. Um, because we keep on talking about the cloud monitoring, and we have best practices and already set places for cloud when it comes to cloud monitoring. But when it comes to edge devices, we are hardly having the best practices because we are completely constrained by the resource requirements. And in spite of having those resource requirements and limitations, you guys pulled off a really great architecture around it. So this is really an eye opener for many of us. And
Yes.
yeah, if we have any questions in the chat, maybe we can take it up.
Yeah, Namish, thank you so much for the session. There's a question in the chat. Maybe you can just answer and post a comment there.
Uh, this was
Yeah, maybe you can take a look later. Yeah, that's fine.
all right. Where can I see the chat actually?
I'll let you know. Yeah. So let's
Okay.
move on. Over to you, Janvi.
Stop sharing.
Well, thank you, Naimish. That was really an insightful session. Thank you so much for that. And next up, we have Senior Architect at Pega Systems, Mr. Abhishek Asthana. So, Abhishek is a senior architect at Pega Systems with close to 2 decades of experience in building enterprise grade and cloud native software systems. And he specializes in microservice architecture, Kubernetes, and platforms with hands on experience across multiple platforms like AWS, Azure, and GCP. And he brings strong practical knowledge of DevOps practices and infrastructure as code, leveraging tools like Terraform to build resilient and cost effective systems at scale. So, he's not only worked with Pega Systems, he has also been associated to Walmart Global Tech, Blue Yonder, Oracle, and TCS. So, we are so privileged to have you, Abhishek, with us today. And next up, we have a session by Abhishek on using Grafana for AI agent observability. So, handing over to you, Abhishek.
Yeah, thanks, Janvi. Thanks, everyone. And I would start with a disclaimer. This presentation is not going to be as interesting or as eye-opener as Emma's. I do not have a journey like her, and uh, I do not have my manager saying good things about me like Namish. So please moderate your expectations. I'll share my screen. Yeah, please let me know when you can see it.
Yes, visible now.
Okay. So the presentation is around using Grafana Bela for AI agent observability. And since it says AI agent, I'm going to parse this title and we'll talk about each of these things. Okay. So starting with the observability part. So what is the true AI observability? We know that there are three pillars of observability: metrics, traces, and logs, right? We all know about metrics, things like latency, in case of AI agents, how many tokens are getting used, input as well as output tokens, what are the cost, error rates, all those things. Traces used in all the applications, any AI or not. So they will give you insight about your workflow. In case of AI agents, about the usage of tools, right? What decision paths it is taking. If AI agent has to reach from a given prompt to certain output, what is the path that it is taking, right? What is the mindset it is using? What are the decisions it is making? So basically, that is the decision path, and that is given by the traces. Logs, we all know. One major point that I added in this, in case of AI observability, is evaluations, and that is it talks about the quality and accuracy, relevance, and safety of the results that it is giving you. Okay, you asked it something, and it is giving you something that is totally incorrect. So it may be good quality, it may be written very well, but it is not accurate. You asked it about Hyderabad temperature in Hyderabad in India, and it is giving you temperature of Hyderabad in Pakistan. Again, it could be accurate, written in good quality, but it is relevant? No. And safety, we all know, right? Remember that famous Microsoft agent which was made racist and totally hellish in one day. So that was when it was lacking on safety. So in case of observability for AI, these are the four pillars. I'll briefly touch over the components of AI agent because this tells us what are the different parts or different aspects of how an AI agent performs. Okay. So first of all is the router. This is the brain of the agent. So whenever you ask agent to do something, how it is going to be is decided by the router. So router only decides what is the next action to do the task. Okay, whether it has to make a call to LLM, whether it has to execute some tool, what all it has to do, all that is decided by the router. The complexity of router can be from very simple to simple, a rule-based engine that if this is the prompt, then do this. If that is the prompt, then do that. To calling LLM and outsourcing the entire decision making to LLM. Okay. The second thing is skills. So these are basically the tools which make an agent do things. Usually we just have these chat GPT like chatbots or copilot like chatbots. You ask it something, it gives you answer. Is it doing something? No. So skills are the ability that make an agent do things. If you are asking an agent to write code for you, then that writing the code is the skill that an agent has got. Okay, and there can be multiple types of skills which can be used by which can be created by using these reusable blocks, like calling an LLM, calling an API, of executing a code in a Python script, or connecting to a DB and running an SQL. So these are the things, and these can be connected to do some complex task as well. Okay. Last of all is the state or memory. So unlike previous old days is like 3 years ago. That's how old this is. So unlike earlier, when your chatbot would have the memory of a goldfish, that you ask it something, it answers and totally forgets the context. Now that doesn't happen, and that is because agents have been given some sort of memory. Okay, it could be short-term memory that it is going to remember only past few conversations. It could be longer-term memory that it remembers all the chat that you had till now, and it is using that. Okay, so whatever is the interaction with the agent, that goes to memory in memory, and that is the context that it uses in the next iterations. Okay, so these are the three components of the agent, and it uses all of these to do the tasks. And for our observability, this is where why I was talking about this component, because for true AI observability, you need to be able to monitor all these three different things. Okay, so for this demo, I just want to quickly show you guys a simple agent which has got a couple of tools. Lookup sales data, I have given it a file, not connecting to DB. I have given it a file, and I'm asking it to look into it and give me some data and then analyze that. Okay. So this is my agent. Do not go into much detail about this. I will show you how it looks. Yeah, so these are the different runs of my agent, and if you see, this is how the different calls are. So this is a Jaeger. So this tool is called Arise Phoenix. This is a open source tool which works on top of OpenTelemetry, and it uses another protocol called Open Inference, which is based on OpenTelemetry. Both the tool as well as the protocol, they are open source. So in this chart here, you can see that different calls that are being made. So agent is making a router call. Router is then thinking, and it is calling LLM. So I'm using GPT-4 Mini. So it is calling the LLM, and it is giving it some question. There's a system prompt, there's the user prompt, and so this is the output of the LLM. Okay, then it gets the response, and then it decides which tool it has to call. So it has to call lookup sales data. So then again, it is asking what was the average transaction value. It is getting some output. Okay, so this is like, if you just zoom out a little bit and see it from a very high level, you will realize that this AI agent is nothing but a simple Python program which is making calls to LLM, giving it some input, getting some output, doing some processing within itself, and taking a next step, right? So on that level, this level of observability, this level of tracing is good enough. But as I mentioned, true AI observability involves using the evaluation also to see how it is performing. Okay. So I have a small evaluation going on here, that is response clarity. So since this is a very simple agent working in a very controlled environment, the response clarity is 1. 1 is like perfect. Between 0 to 1, it is 1. Okay. And if you see these numbers here, so these are other set of evaluations that I have written. Tool calling eval, how good it was in calling tools. Okay, it was correct 95% of time. 5% of time it was wrong. SQL generation was always correct. Response clarity, again clear 94% of time, unclear 6% of time. So the reason I'm showing you this is because I want you to understand what true AI observability looks like. You should have the things like latency, you should have things like the tracing, and you should have the evaluations. Okay, I'll show you the code now. Again, on a very high level. I'll just show you. I just want you to see the observability related code that we have got in this one. Okay. So there are all these Phoenix related libraries, OpenTelemetry libraries, uh, instrumentation code is there. And for each of these, there is this annotation, which is marking that whether this function is for a tool call or this is for a chain as in reasoning chain of thought for the agent. So these kinds of things are there. And if you see again, go down, so we are putting spans and traces, all these things. So basically pretty basic thing which you do whenever you are setting observability for any system, right? So now I want you to take a step back and think a scenario where we were not able to do all of this. We did not have any mechanism to. This was maybe a third party agent. You would have heard about agent marketplaces these days where you can rent an agent or buy an agent, and people are selling agents. So assume that the person who coded that agent did not put all this observability and tracing and span related code in their agent. What would we do then? Would we be totally blind and consider one scenario that I have got an agent running and my system, which is calling that agent, is now showing higher latency. And now, since I cannot put my observability related code in the agent, I do not know what is taking a long time in that agent. Is the LLM call taking long time? Is the call to database taking long time? Is the agent's internal thinking taking long time? What is happening? What is causing higher latency? What will we do then? So that is the problem that we now face, right? And that is the problem that we now try to solve. So this is where Grafana Bella comes into picture. Okay, so what is Grafana Bella? This is another Grafana project, and it is an eBPF based application, auto instrumentation tool. So there are so many auto instrumentation tools. How is it different? Is that it provides observability without code changes or any configuration restarts. So usually if you have to add observability, you have to make some code changes. You have to add some code like I just showed you. Bella is something that it is kind of, you can consider an analogy like it's like a CCTV camera on the road. Okay, and it is showing you who is coming and who is going and doing what. If somebody is coming at what time and going at what time. So in that sense, it is giving you that level of observability without being too intrusive, as in without letting you know that you are being watched. It is watching you. Okay, please don't think about privacy concerns here. This is just for an analogy here. So what it does, it works at very low level. It works at kernel level in the operating system, and it inspects application code, application executables, and whatever is happening in the OS. Okay. So, and since it is able to do that, since it is working at the OS level, it can see really low level of happenings in the OS. Okay, and it captures trace spans for web transactions. So what does that mean? So whenever your machine is making call to any outside word, okay, it is anyways, if it is using an HTTPS or HTTP library to make any calls, whether it is leaving the traffic is leaving the machine or it is internally, if it is using that library, Bella can monitor it. Okay, so it can collects default red metrics for HTTP and HTTPS and gRPC services. I will show you how this looks like and how it works once again. So in this previous slide, this eBPF thing is highlighted, right? So some of you might have questions, what is eBPF? So before we talk about eBPF, and understanding what eBPF is and how it works is kind of prerequisite to understanding how Bella works. And to understand what eBPF is, let's go back to operating systems 101 that we had in college, probably in third semester, where we learned about user space and kernel space. So user space has got all the user level programs like PowerPoint or Chrome or IntelliJ, whatever. And they are talking to hardware. And they are doing that through the kernel. So all the kernel level code, all the OS level code, that is in the kernel space, and it is very tightly shielded from any intervention or any interference from user space. User space programs, like any of the things that I mentioned, they talk to hardware via kernel space, and even to kernel space, they talk via very specific interfaces that are defined. Okay, there is no way that you can run your program in the kernel directly. Okay, but that was till now. So that is where eBPF comes into picture. eBPF was, I'm saying was because it was initially called Extended Berkeley Packet Filter. So Berkeley Packet Filter was a network level protocol that was launched in 1992, and it was actually for packet filtering, and then it was enhanced for other things. eBPF was launched as an extension of that protocol, but later this Berkeley packet filter thing was dropped because it does a lot more than just packet filtering. Okay, so as you can see, the formal definition is language and runtime to extend OS. Now this is very generic and does not give exactly what it does. Okay, so what it does is that it allows us running small programs inside the kernel to observe and interact with the system without modifying kernel source. So as I said, since OS is a very sacrosanct thing, if you start messing up with it, you'll start seeing those blue screen of death kind of scenarios. So that is where not modifying kernel source is a primary concern. Okay, and however good developer you are, you may mess up the kernel source, right? So that is something that is sacrosanct here. And running small programs, that is again a crucial point, because if you run something very heavy, then you may reduce the performance of the entire operating system, and that is again non-negotiable, right? So eBPF gives you this ability to do small things without modifying the kernel source. So I'll briefly go over the components of eBPF, and then we'll talk about how Bella comes into picture and how Bella uses these components. Okay. So first thing is hooks or events. So eBPF programs So you can consider an eBPF program like a very simple, you can even write a simple hello world program, which will run at some specific event. Okay, these programs, they do not uh, run all the time, like they're running consistently watching something. No, that won't happen. They run at specific events, and those events are called hooks. Okay, these hooks can be hooks or events can be system calls, or a network packet is reaching your Wi-Fi port, or function entry when any specific function inside any library is being called. So these are the events. And when you are writing your program, or even you are asking your eBPF program to be run in the kernel, you can tell specific hook when it should run. Okay. So for example, in our case, in case of Bella, or whenever you want to monitor any external HTTP call, you can say, okay, your hook is when network packet is exiting the Wi-Fi port. Okay, so that is a hook. You wrote your program and you want to say that, okay, whenever any call is being made, write my hello world. That will happen. Verifier. So I mentioned earlier that how critical it is that we do not mess up the kernel. Okay, so verifier is the module which checks your program before it is allowed to run, and it has got some very specific criteria. There should not be any infinite loops. You should not be accessing any memory addresses which you are not supposed to. What is meant by illegal? Illegal is something that if you are since you are running as a user, you should not be able to access any kernel memory address from your program. You can probably access any user memory address, but not any kernel address, because you may corrupt the OS then. And the third thing is it too big to slow down the system? The performance is most important here. So once again, is your program too big, or has got too much stuff going on, or it is making too many calls, which is going to slow down the system? Verifier will not allow it to run. So JIT compiler, this is the most interesting thing here, because whatever code you have written, it will be translated to a specific bytecode of that processor. Okay, so if it is x86, like in case of Macs, you have got Apple Silicon or Intel, so it will be translated into that particular bytecode. So you can now understand at what level this thing is working, that we are talking about writing binaries here, right? So it is translating it to bytecode of the processor, so that it will run extremely fast. Okay, this will have ultra low latency, so that the system performance is not hampered. And the final thing is eBPF maps. So you saw the user space and kernel space. How is the data going to transfer between kernel and user space? That is through these eBPF maps, which acts as a bridge. Okay, so kernel will write some data in that map, and the user space will be able to access it. Okay, so these are the 4 components of eBPF. How does this whole process work? So just very simple scenario actually. So let's say you wrote your program, your hello world program, you compile it to bytecode. So to compile it to bytecode, there is a specific C compiler which runs, and it converts your program to specific bytecode. Then you only will make a system call and you will load into kernel. So whatever these white boxes are, these are what developers' responsibility is. The blue boxes are kernel's responsibility. So you have written the code, you have compiled it, you have loaded into kernel using the system call, and the verifier will run its checks, the 3 checks that I showed you. Then the JIT compiler will compile it into the system-specific bytecode. It will return a file descriptor, and then once again you will decide. Now, since you are the writer of the code, you want to decide when it should run, at what hook it should run. So once again you will make another system call, and you will attach that your program to that specific hook. Okay, so once that is done, your program will run on those events. So whenever an external call is being made, any network packet is reaching the Wi-Fi port, and you have attached your program to that particular hook, it is going to run on that, and data will flow via the eBPF maps that we talked about earlier. Okay. So where does Bella fit into all of this? So let's look at this very simple diagram. So Bella, in our case, Bella is the developer. Okay. So Bella has already, so whenever you deploy Bella on your machine or on your network, Bella has already got the compiled code in its binaries. Okay. So it is not running that C compiler, specific C compiler to generate the compiled code. It already has got it. And Bella loads that code into the eBPF. Okay. And then once that is loaded and it is attached to the hooks, then it starts, it attaches a couple of probes. There are different types of probes. I will talk about them in the next slide. K probes, which are listening to the kernel space events, and the U probes, which are listening to the user space events. Okay, so it associates the K probes with the system events and U probes with your app. So in my case, that AI agent that I wanted to monitor, it starts observing that. Okay, and whatever data is being generated or logs are being generated, events are whatever event log is happening, that is written to the eBPF map, and then Bella simply reads to this one. Okay, very straightforward. Once you have understood how eBPF works, Bella is simply using that. Okay, so how Bella works? So Bella works in a pipeline manner. So there are different components, and these components do one thing at a time, and they pass the output to the next component. Okay. So the first component is discovery. So as I showed you earlier, when I was talking about why Bella, so like in our case, now my agent is running on my machine and I want to monitor it. Okay, my CCTV camera is there. I want it to understand what it has to monitor. I want it to monitor, let's say, red color cars. Okay, so there can be 10,000 types of cars coming on that road, but I want only the red color cars to be monitored. Okay, so my camera is going to scan the system for all the different types of cars that are flowing, and then it will figure out, okay, these are the red cars that have to be monitored. Okay, so I will show you the configuration code which Bella uses for actually monitoring or identifying which process it has to monitor. Okay, and that is the piece, the part that discovery handles. Okay, so once discovery has identified the processes that it has to monitor, the eBPF tracer comes into picture. Okay, so whatever in the previous slide I showed you, the almost entire thing is the task for the tracer, eBPF tracer. So this guy only, it injects the probes and captures raw data. Okay, this only contains the actual eBPF code that is being pushed into kernel, right? So we talked about the K probes and U probes. So those are the two different probing mechanisms. Okay, so K probes, they are used to monitor the kernel events, and U probes for the user space events. Okay, so for example, in my AI agent scenario, whenever any call is being made to call made through HTTP, the U probes are going to look at that, and K probes are going to listen to whatever is happening on the Wi-Fi port. Okay, so these two are the different types of probes that this tracer has got. So once it has connected those hooks in the corresponding space, whenever any request is happening, whenever any that event is getting triggered, the probe triggers. Okay, and once it triggers, it starts capturing the data. So now, like previously I told you that everything is happening at the byte level. So all the data that is at the OS level is in bytes and in the binary level. So all that data is also very, very granular. But to show it to the user, it has to be translated into human readable format, and B, it has to be reduced a little bit. Okay, there are, if the data is extremely vast, it will be very difficult for us to consume. So that is the job for this transformer or reporter. What it does, it is reading the data from the eBPF maps. Now it is going to process them, convert them to some sort of understandable format. It will filter, it will group the data in in a way that it reduces the volume as well as makes consumption easier. For example, let's say there is one API /v1 /user ID 1. Another call is /v1 /user ID 2. Okay, there can be hundreds of these different routes. So rather than giving details about each of these routes individually, it can simply do it /v1 /user ID. Okay, so now you can see how is this endpoint working. Okay, so all of this stuff is done by the reporter. And finally, the exporter, which sends data to any of our backend systems using OTLP or Prometheus endpoints. Okay, so this is the total how this Bella pipeline works. Okay, a lot of theory. I'll go to the demo piece. So we've already seen how Phoenix works. So now I'm showing you a simple dashboard that I have created here using only the logs or the data that is coming from Bella. Okay, so these logs, these are the Bella container logs. And if you see here, there is this post/agent query. Okay, this is an endpoint that I have exposed. And whenever it is being triggered automatically in the code, or I'm doing through Postman or something, it is going to be listed here. So you can see here that it has got the timestamp, it has got the latency, it has got the status, it has got the endpoint, it has got the ports and the network addresses, it has got the request and response byte sizes, it has got this is like the AI agent eBPF, this is the process name, and importantly this has got the trace IDs. So these are the distributed trace IDs. Okay, so if you see here, I can actually do the tracing here, and this is without any observability related code in the agent code. Okay, so if you see here, whenever the agent/query call is being made, it is making call to LLM. Couple of calls are being made to LLM. Then this is an internal call that it is making to itself for basically a tool call. This is how much time it is waiting in queue. This is how much time it is doing processing. So it is giving a very granular level of tracing, and all of this without a single line of code. So that is pretty useful when you have got a major handicap like not being able to write any code. This is the request per second. So I had earlier mentioned that it generates the red matrix, request errors and duration. These are the errors that are getting generated in the system, and this is the latency. So here I have marked the latency for the LLM calls. So you can see this blue line, it shows the latency for the LLM calls is much higher than anything that is happening internally. Any tool calls that are there, it is taking much less time. So once again, it gives me some sort of observability, at least that what is taking more time whenever any call is being made to the agent. Yes, it is the LLM call is taking the maximum amount of time. And if I want to somehow optimize this, I should be able to do that. Okay. I'll show you the code, how this has been configured. So this is my AI agent. So currently everything is running in Docker on my system. This is exposed at port 5000, and this is how Bella is running. Okay, so if you see here, I have told Bella to monitor port 5000 and port 443. So 443 is for an external calls that are going through HTTPS, and 5000 is the port on which the agent is running. So any internal calls that are happening, they will be monitored on the port 5000. I have given it the OTLP endpoint where it is going to send all the data that it is collecting, and my Prometheus, Grafana, and Jaeger, all of them are using this endpoint. Okay, I have given it the service name. In the logs, you would have seen this AI agent eBPF. So it is registering everything using this service name only. The executable name is Python. So once again, you would have seen this in Python and the logs also, that it is the this is the executable that it is monitoring. Okay, and this is just that AI agent and hotel collector. These are the two services that it is dependent upon. So if I stop AI agent or hotel collector, Bella will also stop, and then I will have to restart it manually. Okay, so many uh, of these Bella sessions that if you will watch, they will sell you Bella as one-stop shop for all observability, which I'm afraid it is not. Okay, the reason I showed you Rise Phoenix and all those evals and the components that I was observing in the very beginning was to give you an idea what true AI observability means, what all parameters we really need to watch for a safe and performant AI. Whatever I showed you in the second demo, the red metrics, the logs, basic tracing, they are very good when you do not have the ability to monitor, but they are grossly insufficient. Okay, so even though you can see that yes, LLM is taking long time, you can see that okay, how much time it is taking for each LLM call or internal call or in queue, in processing, all those things you could see in the tracing, you could see basic logs, you could see errors, all those things. But the problem was that the business context was very limited. Okay, unless until you really are uh, in a shape that you cannot add any observability, you should not be using such kind of observability. Okay, so business context is very limited in the second scenario, right? Important thing is, the second thing is that it is working only with Linux kernel. Okay, for any older kernels or even Windows, this does not work. Okay, protocol coverage is limited. HTTP, HTTPS, gRPC, these are the only protocols that are covered right now. So the simple reason is that since you see everything is working at the binary level, bytecode level, so any kind of support either at the Bella level or at the service level comes very slow, right? So that's why protocol coverage is very low. Granularity again is very low. It is definitely not at the level you would want, but as I have been saying, it is better than flying completely blind. So this is how Bella can be used and Bella should be used. It is not a one-stop solution for everything, but it gives you very good visibility when you do not have any means to add any observability. Yeah, that's all from me.
That's a very good explanation, Abhishek, especially about the eBPF part, right? Whatever you put together. So if another simple example to relate eBPF for is like if you are using Kubernetes and if you are using Cilium for networking, I think it has a eBPF data plane, so a lot of people can relate whatever Abhishek has explained. One question from my side, Abhishek. So since it needs access to the kernel space, right? So if you're trying to auto instrument an application, so it would need access to that bit namespace. The Bela, if it's running in a container, so it would need privileged access. Is that right?
Yes, yes. So Bella configuration is very flexible. You can tell it how to monitor for a specific process. So like in this case, I told it what ports to monitor. You can tell it what namespaces to monitor. You can tell it any specific service name. All those things are there. So yes, you will need that kind of privileged access there.
Thanks. Thanks for your explanation, Abhishek. That was a great session.
Yeah, thank you.
This is really great, Abhishek. Uh, I completely correlate with the explanation because right now we are on the verge of moving towards AI-driven observability, meaning observing the AI workloads from the traditional observability. And I think Grafana Bella looks promising right now because I got to know that it is on open source and we don't need any Grafana Cloud license kind of. So it's pretty good in that context. But is it just you are going to instrument the application with any SDK specific to Grafana Bella, and then you are giving the endpoint of hotel collector, and that's it from the maintenance perspective? Is it so, or do you see any complexities associated with it?
Right. So in this case, there is not even any SDK. So just that Bella is running and it is observing that particular port or that particular service. So you are not you whatever you are doing is just running it and telling it what to do and what to monitor. That's it, and that's all it can do. Also, it is limited in its abilities, and it's up to you how you can use those abilities. So uh, you can probably whatever metrics it is giving you, how you can use those metrics to understand your system, figure out issues with your system. In case of any errors, do any debugging. That will be totally up to you.
Okay, so we need that Bella as a container running beside in our cluster in order to keep on continuously monitoring the endpoints
Yes,
that we configure.
right. Yeah.
Okay. Mhm. And how that does play when it comes to multi-agent ecosystem, meaning my agent is talking to some other agent in another region using
Mhm.
ATF protocol or whatever the agentic protocols. So
Mhm.
will Grafana Bella running in my cluster have the visibility to the agent that is running remotely somewhere else?
So once again, the Bella will be able to see how whatever your agent is calling. Okay, it will get the sorry, it will get the responses from that system, and those responses are going to come to the port that you have exposed. It is going to understand only that much. So, for example, in this demo, this guy was calling OpenAI, right? That GPT-4 mini LLM. What LLM was doing, what it was sending, it was unable to capture that, right? So if your other agent is running in some other system, Bella will not be able to observe that. It will be only able to observe whatever your process is doing because it is monitoring your process. Whatever is happening in your system, it will be able to monitor. Other than that, it cannot do anything.
Yeah, makes sense. Thank you.
Thank you.
Well, thank you, Abhishek. That was wonderful and insightful session. Thanks for joining with us today and all the speakers. It was been such an amazing session. Naimesh and Ima, thanks for joining. And this is our first ever virtual event and also the end event for December. I hope we all wrap the session well and end with full of insightful sessions towards observability. So thank you for making that possible, all of you who joined today on the board. Thanks to Satpal, Rishi, and Rahul as well, the co-organizers and organizers of Grafana and Friends Hyderabad. Thank you once again for all of you who joined us today.
Thank you, everyone. Thanks, Janvi.
Thank you.
Yeah, just a note before we leave, right? So I wanted to share the bento link where we have all the socials for Grafana and Hyderabad, Grafana and Friends Hyderabad community. Let me share my screen. Okay. So here's the bento link. It's already chatted in the live chat on YouTube. So here we have our socials, the meetup group, the LinkedIn page, our Slack community. Join the Grafana and Friends Hyderabad dedicated Slack channel where we'll be posting all the content related to the Hyderabad community. And here we have a feedback form where you can let me share that form as well, right? So if you would like any topics in our upcoming meetups, the format of the sessions, and if there are any sessions to improve the meetups, if you want more virtual events, in-person events, you can submit the feedback. We'll definitely action on this feedback. Yeah. So, and thanks again to the amazing speakers, the coordinators, the volunteers, the co-organizers, whatever we call, basically the community contributors, I would say, to make this event a milestone for Hyderabad community, because there was lot of ask for a virtual event so that the sessions get recorded. People can go over these sessions, and today, thanks to Naimish, Abhishek, Ima, the content we had today was really insightful. I think the audience, the attendees, can definitely take away from these sessions and apply them in their workplace or personally if they want to develop develop their skills in the observability space or develop their observability skill set. Yeah. Yeah. Amazing. Yeah. And thanks a lot again, and thanks everyone. See you till the next time. Yeah.
Thank you.
Thank you, everyone. Wish you a
Thanks,
happy
everyone.
new
See you
Wish you
soon.
happy new year and Merry Christmas.
Thank you.